All right, everyone, now that we have established why we have to use this on the low range versus this one, I want to talk about a couple more things about the difference between these two meters before we move on, okay? And the first one I want to talk about is that we have selectable ranges, and that's because we have only so much power that we can put out of this test set. And so power is equal to amps times resistance. And that means that if I put out 10 amps times 10 amps, I have to have a very low resistance, or I have to put out a lot of power, right? Just even if it's 5 ohms trying to measure, 5 ohms times 10 times 10 is 500 watts, and this little battery ain't gonna push it, okay? So that's why we have selectable ranges for our current. And just to kind of prove that along the way, we already proved earlier that this one, and I'm gonna demo it real quick. This one, when it measures resistance, right, we are going to measure a voltage across it. And so what's the resistance of this meter right here? I'm just going to try not to touch these leads, because if I do it, I'll use my skin. But if I go ahead and I just measure the resistance, there we go. It's putting out 2.7 volts at 10 mega ohms. So this meter's input resistance is 10 mega ohms, and it's putting out 2.7 volts. And then now let's go ahead and change this to current, okay? And just to kind of to prove that that's what we're measuring, I'm going to, well, what am I measuring right here? I'm going to do the exact same thing, but now what I'm actually measuring is I'm measuring the internal fuse of this guy, because it's in series to prevent you from smoking your meter. So now if I measure that, you can see it's 2.8 ohms. That's what we're getting. That has to do with all the leads here too, right? And then it's at 1 milliamp, right? If I take that off, it goes away. So that's definitely, it's running a milliamp. 1 milliamp, and it's able to measure a voltage, okay? So that's how these things work, but they're very low, or they're not intended for these very low ranges. This got to 1 milliamp, and it can't get much lower than that, okay? This thing can put out 100 microamps and be calibratable at that range. All right, so now that we've gone over that, let's get this junk out of here. These aren't what we need we need the right tool for the job. So we're gonna slide these out over here, okay? So what I've done with this guy is I've changed it up a little bit. We've got the normal leads hooked up that I use, but I also plugged in a second set of leads that are in parallel with it. They have no effect. You can use both sets of leads. It's basically just a duplicate. It's like plugging another set of leads in. You can do whatever you want with it, okay? So I'm gonna turn this meter back on, and I just wanna show you that I've got the normal leads right here in my hands, and this thing's set up to run, and if I go ahead and I test, it's going to run just normal. And you know, it's always good to do a functions check. First thing you do, you go right there. That's a short, good. When I first turn this meter on, or any meter like it, the first thing I always do is I say, let me just dead short it. I should expect a very low reading, right? 14 micro, that's a reading that I expect, okay? That's a functions check. And then the next thing I do with this meter specifically is I do further away. I expect my reading to go up, because I'm now measuring across more conductor, and it has a higher resistance the longer conductor. All right, so now that I've done this, I just want, before we get into the next video, I want to show you that you can break out your leads, okay? And these are our leads right here, and I have, blacks are my voltages and reds are my currents. And so I'm going to apply voltage there and current here, and that's my bus. And then I'll come down here and I'm going to apply a current here and a voltage here. And this is why I use these leads specifically, okay? Is I wanted to show you that we're applying a current from this end to this end, and what we really measure is the voltage drop, right? Because in order to calculate a resistance, we need a voltage and a current, and the voltage that we use is going to define our reading. So if I measure my voltage there, or if I measure it here, the number gets lower and lower the closer I get, because even though my current is still traveling from that end to this end, it does not matter. What matters is the fact that where I measure my voltages. And I'm gonna take this one off, and I'm gonna go the opposite direction. It does not bother this meter. This meter is not polarity sensitive, right? So if I put it back around the same spots, I got 430 and then 441, right? What matters is where we put our voltage leads, okay? The last thing I'm gonna do before we close this video out is I'm gonna put my current. Now I've got my current going from here to here, and this is what I want you all to ponder on, right? I love to show this demo, is I'm gonna put my voltage right here, and I'm gonna go right here, and we expect it to be 464, good. I'm gonna go right here, we expect it to be higher for sure, right? A little higher. Then we expect it to be a little bit higher. Now my question to you is that once I get past this current lead, what do you expect it to be? I want to pause for a second, let you think about that. If I go past it, what happens? I'm not going to get much higher than 725. And why is that? Because it doesn't matter if you measure the voltage at the light switch or if you measure the voltage at the light bulb, it's still 120. The voltage drop that I have across this resistor right here, this bus is a resistor. The voltage drop that I have built across it with that 10 amps doesn't get any higher no matter how far I go out, okay? Got some lightning in the background. So that's why this number won't go any different. And I'm not doing anything crazy. If you go back over here, it's gonna keep going back down just like we expected, okay? If I leave this one here and I go over here, we're gonna go right there, we're just past it. 263, if I go over here, we're expecting still 263, okay? Where you place the leads matters, where you place the voltage leads matters, and where you place your current leads will matter, and that is going to be what's crucial in the next video. Thank you.